Hi everyone, welcome to Managing Your Machine Learning Lifecycle using Databricks and MLflow webcast. Thanks for joining us today. I'm Sanjula Krishna. I'm a senior BI and analytics consultant with Thorogood Associates, and I'm based out of London, United Kingdom. Before I get into the details of the webcast, I'll just give you a quick overview of Thorogood for those who are not very familiar with us. We are an independent business intelligence and analytics specialist consultancy with operations in the UK, US, Brazil, Singapore, and Singapore. Our core business is the design and development of business intelligence and analytics applications, but we also provide a full range of services, including strategies and roadmap training and user adoption and support and data services. We are an independent professional services consulting firm, and we work with a wide range of tools and technologies. Obviously, Databricks is an important partner, and we are talking through their tools today. But also of particular relevance, we are partnered with both AWS and Microsoft with their Azure platform. Databricks is available on both platforms. I'm going to be showing it in the AWS platform today. Let's quickly take a look at the agenda for today. So first up in the presentation, I'm going to talk about the data science project lifecycle, followed by the challenges that are generally faced with machine learning lifecycle in particular. Then I'm going to talk about Databricks and MLflow and how they help with addressing the challenges. Finally, I will take you through a demonstration of a customer churn model, which is for an internet service provider company which is trying to look at the customer churn for their data set. Let's get started. So if you're already aware of the data science project methodologies out there, today we are going to talk about the CRISP-DM in particular, which is cross-industry standard process for data mining, which is a preferred approach for data science projects. So to briefly introduce the approach, you start off with a business case for conducting some analysis with a thorough understanding of the business process and identifying the decisions you think you can improve by using the data science. Then you assess what data you have available, whether it is sufficient to meet your needs, then progress to prepare the data for analysis. Then we develop models and evaluate the suitability of the model for the business decisions. Once you're happy, the model will give you the useful insights to improve your business processes. You need to deploy them for the use in the business. And as you can see, this isn't a linear process. An analyst will move backwards and forwards between the different steps to continuously assess the suitability of both data and models in meeting the end goal, even starting again, sometimes reassessing the business process and reframing the business questions as required. So in this life cycle, there are various challenges in pretty much every step. Now let's look into what these challenges could be in data science project lifecycle. So this is a famous slide shared by Databricks, originally published by Google. You can see all the capabilities that a company needs to be successful at artificial intelligence. The ML code is the smallest green box at the center. Everything else is about collecting, verifying, preparing data, configuring, and managing cloud scale infrastructure. So that's where the heavy lifting is. You need to get all the other parts right in order to ensure your green ML code is a success. As we all know, machine learning requires experimenting with a wide range of data sets, data preparation steps, and algorithms to build a model that maximizes some target metric. Once you have built a model, you also need to deploy it to a production system, monitor its performance, and continuously retrain it on new data and compare with alternate models. Being productive with machine learning can therefore be challenging for several reasons. So first and foremost is how can you do artificial intelligence if you have no data? You can't. But even worse is what happens to your artificial intelligence or ML projects, specifically ML projects, if you have the bad data. So for this reason, you need reliable data, both in terms of quality and storage, to run your data science project successfully, especially when you want to do analytics at scale. You need efficient data engineering techniques and tools to be able to achieve the results you expect. Next is with tracking the experiments. As we all know, machine learning involves a lot of experiments that have to be run. When you're just working with your files on your laptop or with an interactive notebook, how do you tell which data or code or parameters went into getting the particular result? Tracking versions could be the next problem. Even if you have meticulously tracked the code versions and parameters, you need to capture the whole environment. For example, library dependencies to get the same result again. This is especially challenging if you want another data scientist to use your code, or if you want to run the same code at scale on another platform, for example, in the cloud. With ML, there is no standard way to package and deploy models. Every data science team comes up with its own approach for each ML library that it uses, and the link between the model and the code and the parameters that produced it is often lost. Also, there is no central store to manage models, the versions and the stage transitions. A data science team creates many models in absence of a central place to collaborate and manage a model lifecycle. Data science teams face challenges in how they manage model stages, from development to staging and finally to archiving or production, with respective versions, annotations, and history. Moreover, individual ML libraries provide solutions to some of these problems. For example, model serving. To get the best results, you usually want to try multiple ML libraries in your project. What we are going to look at now is how Databricks and MLflow combination can help us with efficiently managing these challenges. For those of you who are not familiar with Databricks, so I'm going to answer the question, what is Databricks? So Databricks builds on open source Spark platform. Spark is a popular platform for running data analysis and machine learning at scale, and the team who originally came up with this with Spark have formed a new company to launch Databricks. So Databricks takes all the advantages of the Spark platform and extends it to make it easier to set up and use, and makes it easier, ready for the enterprise. One way it does that is by integrating with Azure and AWS. Spark requires a cluster of computers to be set up, and Databricks automates this process, so it's as simple as choosing the number of computers and their size, and Databricks handles the rest. On top of that, Databricks will handle auto-scaling, so you only pay for the compute power you're actually using. That can mean big savings if you're running occasional analysis that needs lots of compute power for short periods of time. Another way that Databricks builds on Spark is by adding notebooks, which allow users to work in a mixture of languages supported by the Spark platform, whether that's SQL, R, or Python, choosing whichever language the user is most comfortable with, or whatever is the best for the task at hand. It also has a number of most popular machine learning frameworks built in, again simplifying the setups. Databricks also has enterprise-level security built in, and a number of other enterprise features for collaborating and integrating with a number of front-end BI tools. The next is why Databricks is becoming popular. So these features combined are making Databricks a hot technology at the present, and really we see the interest across two main types of use cases. The first one for data engineering and ETL at scale, and particularly with more companies embracing cloud data sources and the data lakes. Databricks offers a lot of flexibility to connect to a very wide range of data sources and file types, and to use, say, Python scripts and libraries to transform the data and then output to, again, whatever file type or data source you need. On top of that, the ability to scale the compute power up when needed and then turn it off when you're done means that you can run your processing much quicker than you could if you were having to pay for computers to run all the time. For the data science use case, the flexibility to switch between the languages and to use whichever ML framework you need to approach a business question is a massive plus point for Databricks. On top of that, the notebooks allow users to take notes among the scripts so that the data scientist can explain all the steps they are taking and hand over the output as a report, ensuring that whole analysis is documented and repeatable should any questions come up later. So now I'll introduce you to Delta Lake. What is Delta Lake? Delta Lake is an open source storage layer, and it runs on top of your existing data lake and is fully compatible with Apache Spark APIs. Its main purpose is to bring more reliability to data lakes. The data itself is stored as version files in Parquet format, which is useful as this format works with a vast range of tools. So we see its unique selling points as assured data integrity with ACID transaction. ACID is atomicity, consistency, isolation, and durability. You can trust you have a valid version of the whole data, which will be unaffected by the concurrent executions and system failure. Scalable metadata handling. This guarantees that no matter the size of the metadata table, it will be processed easily. Schema is easily enforceable with Delta Lake. Therefore, there's no concern over data structure or format. For instance, if you try to append data with incorrect schema, it will throw an error. It will also deal with missing information, such as applying the current partition to any appending data. Unified batch stream means that you can be sure a table in Delta Lake is always the most up-to-date data, as Delta Lake handles both batch and streaming sources of data. Audit history, time travel tracking. This feature has many names, but basically it allows you to check on the changes that have been made to the data and select older versions of the data. All of this is added to the completely scalable data lake platform, and all of these features are designed to work really efficiently at that scale. Now, Databricks have open sourced the technology behind Delta Lake, but the Databricks software has optimizations for Delta Lake built in. So if you're using the Databricks platform with Delta Lake, you get the best performance and all the features you expect from Databricks, such as collaboration and flexibility, flexible compute power to run it, along with all these advantages that you'd normally expect from a relational database platform. So coming back to key challenges, we saw how Databricks can help with addressing one of the challenges, which is your reliable data. Now let's focus on the challenges very specific to machine learning lifecycle. It is clear that ML development has to evolve a lot to become as robust, predictable, and widespread as traditional software development. To this end, many organizations have started to build internal machine learning platforms to manage the ML lifecycle. For example, Facebook, Google, and Uber have built FB Learner, Flow, TFX, and Michelangelo to manage data preparation, model training, and deployment. However, these internal platforms are limited. Typical ML platforms only support a small set of built-in algorithms or a single ML library, and they are tied to each company's infrastructure. Users cannot easily leverage new ML libraries or share their work with wider community. Let's take a closer look at the machine learning lifecycle to be able to talk about how MLflow can help with the machine learning lifecycle challenges. So when you go to create a statistical or a machine learning model, assuming we have identified the specific business question and the data needed to support it, and the data is all formatted exactly how we need it, there are a few steps required to actually build the model. First, we'll choose a model type, depending on the type of the question we are trying to answer. For any model type, we need to specify a few hyperparameters. Then we'll need to train the model on our data set and review the results to see how accurate and how precise a model we have. And we don't just do that once. Typically, that's a process that we'll repeat many times over during the course of the project, with the aim of building more and more accurate models until you reach a model that you're happy to use to make decisions or change how you're running the business. So this is where MLflow comes in. About MLflow, what MLflow provides is 4 components to help manage the ML workflow. MLflow tracking. The first is MLflow tracking. It's an API and UI for logging parameters, code, versions, metrics, and matrices and artifacts when running your machine learning code, and for later visualizing the results. You can use MLflow tracking in any environment, for example, a standalone script or a notebook to log the results to local file or to server, then compare multiple runs. Teams can also use it to compare results from different users. MLflow projects, that's the second component. They are standard format for packaging reusable data science code. Each project is simply a directory with code or a Git repository, and uses a descriptor file or simply convention to specify its dependencies and how to run the code. When you use the MLflow tracking API in a project, MLflow automatically remembers the project version and any parameters. You can easily run MLflow projects from GitHub or your own Git repository and change them to multi-step workflows. So then we have MLflow models. MLflow models offer a convention for packaging machine learning models in multiple flavors and a variety of tools to help you deploy them. Each model is saved as a directory containing arbitrary files and descriptor files that list several flavors the model can be used in. MLflow provides tools to deploy many common model types to diverse platforms. For example, any model supporting the Python function flavor can be deployed to Docker-based test server, to cloud platforms such as Azure ML and AWS SageMaker, and as a user-defined function in Apache Spark for batch and streaming inference. If you output MLflow models using a tracking API, MLflow also automatically remembers which project and run they came from. And finally, the fourth component is the MLflow registry. Offers a centralized model store set of APIs and UI to collaboratively manage the full lifecycle of the MLflow model. It provides model lineage, model versioning, stage transactions, and annotations. Up next, you can see it's just a screen share of how MLflow models can be compared in the MLflow in Databricks. We have got multiple runs shown across the columns with a list of parameters that we use for each model, shown along with the evaluation metrics that allow us to compare the results. I'll take you through this in the demo. It's just a snippet to show how it looks like. Before moving on to the demonstration, I'd like to bring things together. So we saw the challenges, the overall challenges with the machine learning lifecycle. We saw how Databricks and MLflow can help. This view here just shows the entire Databricks stack as to how things come together. So with Databricks, you have access to your enterprise cloud service. You have efficient data storage in terms of storing it in terms of Parquet format. Databricks provides you data engineering capabilities with the ability to use your language that you're comfortable with. And then it also provides capabilities with data science projects by allowing you to access multiple ML algorithms and libraries. So MLflow, so that comes under the data science workspace. Then you have access to BI integration tools such as Tableau, Click, Power BI, Looker, which can then access all your data that you have been working with. So without any delay, I will take you into the demo. So today, for the demonstration, we have a model for customer churn. I'll just give you a quick background of what the use case is for this model. So in this scenario, we have a clear business goal for an internet service provider. We want to reduce the number of customers leaving our service. In terms of a question we can answer using data science, we look to identify which customers are most likely to leave, and then we can decide whether we want customer service to give them a call or give them some sort of an offer, something that makes them more likely to stay with us. And obviously, what we have got here is just an example number, but it's always good to identify the business value upfront. Data understanding, the data we are going to use for this, we have got a data on current customers, and we have got data on customers who have left in the past, so we can look for patterns of behavior. Examples of that include first order date, most recent order date, any information we have recorded on the contact they have had with the customer service, or how they are ordering or using the product. All of that can go into building up a pattern that allows you to predict which customers are most likely to leave. So here we have multiple tabs. So I have a model where I'm processing ML code. I'm running a couple of algorithms. Before I jump on to the data science aspects of it, I'll just, if you're not familiar with the Databricks interface, I'll just talk you through how things work here in Databricks. So as you can see here, you have workspaces, you have clusters, data, jobs, models. So you can create a cluster by going into this cluster panel. You can choose. So today I'm using TGDB ML demo, and I've picked out the specification that is required for ML for running an ML code for today's demonstration. I'll not dive deep into it. You can watch our webcast on Databricks for data engineering, which covers most of the data engineering aspects in detail. So with that introduction, I will quickly jump on to the workspace. So today I'm having my demonstration documents in this workspace, which is called CC Demo, and these are the notebooks that I've created in order to demonstrate the customer churn model. So in the first customer churn pipeline, what we have, as you can see here, you can choose which cluster you want to add to, and you have the code written down here. So this primarily uses Python, and you can see I have loaded the file and I have run multiple algorithms. So while doing this, I have the ability to look at the data, do the data exploration as well, whether I'm doing the process right. So here I'm going to just hit run all. Conscious of time, I'm just going to hit run all so that you can see the data process. So this is one experiment that I've run, and in this I'm creating an experiment for today, which is called customer churn, and it's based in this location. So once this run completes, I can show you what are the different algorithms that has been run as part of this. So you can see that it's all done. I'm going to just go into this, which is the customer churn, which is my experiment, and I'm going to open a new tab. So as you can see here, all the experiments, the different models have been run. If you want to know with the accuracy as well, so you can see the different matrices across all the columns. So say, for example, if I just want to compare all the runs within the current model, I can just select on them and hit on compare. So this gives me a view of what model I have run and what are the different data sets and parameters that have been used, and what are the different matrices that I've got as a result. So there is a small little visualization here which you can use. Again, there are different plot types, so up to you to choose whichever you want. So for now, I'm just going to look at this model. And yeah, so this is a run ID, which is key for deploying the model, which I'll be showing soon. So here I've run the data, I've run the processor models using 3 data sets, as you can see here. I have another notebook which has some additional data sets, so I'm going to just run it now. So in this, I'm also doing some data engineering parts, but conscious of time, I'm not going to talk about it in detail. There is a detailed webcast available on that. Please feel free to watch it in our perspectives page in our website. So this is done. So now when I go back to this and refresh, it's all run under the same. You can see a few more which have got added now. And now if I compare all of the runs for today that I've done, you can see the KPIs side by side. The most recent 5 runs, in the most recent 5 models show that they have been run on 4 data sets. The previous ones were run on 3 data sets. So you can, this is quite useful with regards to MLflow, and you can see how this could be helpful for the data scientists or analysts who are running these algorithms. Then I'm going to show you some data exploration. So here in the steps, you can see, I'm not going to run it, but I've already pre-run it for demo purposes. So you can look at what is available and what is the unique count and all of that. So here you can see the customer ID count, unique, the frequency, who's the top customer, and more details. Then after I do the data exploration, so by types of service, you can see the customers. So after I do all the data exploration, I can switch to the data structuring part. So here, again, these are a set of codes I'm just running to structure the data. So now what I can do after I run these is I can deploy the model. I can go back to this churn and I could pick one of these. So if I'm happy with one of these models or multiple models, I can choose the model. So let me just click on one of the model. You can see more details in terms of what it is and again the parameters that we saw in the compare view. But at the same time, here you can see the artifacts as well. So if you're happy with this model, you can choose to register this model. So I'm going to say create new model. I'm going to call it customer churn, and I can register this. So once this is registered, you can find this here, and currently it is not in any stage. So as I mentioned, if you want to manage your lifecycle, you can do that using this pane here. So you can choose to change the stage. Here, you can say transition to staging. If you want to make it production, you can transition to production. If you want some model to be archived, you can change that too. Then I'm going to run another block of code where I'm going to use a different data set and deploy and use it on one of the models I've already deployed. this is a completely different data set that I have. So previously I was using the service opt4. So if you had noticed when I scroll through, I would have used the different file. Now I'm going to try and apply a different data set onto the model that I already have deployed. So I'm going to hit run all, and you can see it's done within seconds. So the new data set has been applied to the model that I've built. So that brings us to the end of this demonstration. So before we wrap up, I would like to quickly mention the previous demos that we have done. It's a series where we have talked about Databricks for data science and for data engineering. So if you have missed it, please do watch it in our perspectives page. It's available in our website. If you want to discuss any of the topics that we covered today, or if you anything related to Databricks, or if you think Databricks sounds like a good fit for your organization and want some help getting started, please reach out to us. We have helped a number of customers with Databricks, and we are happy to help you think through how it will work best for your organization. Why build a number of models that we want to test. Thanks for joining us for today's webcast.